Good morning, my dear students of class 10. Today we'll be going with the electrolysis. During the process of electrolysis, we'll study about the selective discharge. Often you might be confusing that which ions will discharge where and where the ions will get migrate over there. The very first thing is that what we have to understand is the electrochemical series of metals and the electrochemical series of anions. So first we'll find out the electrochemical series of anions. The very first thing is sulfate. You can write here SO4 2 minus, then nitrate NO3 minus, then chlorine, bromine, iodine, OH. So these are the electrochemical series in anions. So this you must remember from the anion part. And in metals, the electrochemical series starts with potassium, then sodium, calcium, magnesium, so this is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, silver. After copper, then comes mercury. Okay, mercury. Then after mercury, we have silver, gold, and platinum. Now, first, what you have to understand is, now the more you go to the downward, the more they will discharge easily, whether you can go with the cations and anions. Here also, more you go to the downward, it is easy to discharge there properly. So first we have to know this, and under the identical conditions we have to understand that there are three factors how and where they will discharge. The very first thing is that we will see this when the solution has been, the electrolyte has been taken as dilute. The condition number one is the solution, the electrolyte must be dilute and it must be inert electrode. We have two types of electrode. One is inert electrode, another is active electrode. Inert electrode means we get here graphites as one of the inert electrode, or we can take here platinum as well. Whereas for active electrodes are, we can take Ag, nickel, copper, etc. So first we will try to understand the electrolyte has been taken as dilute, and the electrode which is used is inert electrode. In that condition, what we will see the discharge over different electrodes. Let us take as copper sulfate solution. So this is copper sulfate. So when this breaks up, it becomes Cu2 plus SO4, and here we get H2O as H plus plus OH minus. Now the very first and foremost in this condition, what we have to understand, where this will, in which electrode they will migrate. My dear students, remember C to C, C to C, A to A. C to C means cations to cathode, anions to anode. Now that means what? You have understood this one. Here we are getting here cations as copper and hydrogen. Both are cations, so they both will try to migrate towards cathode. But the condition is that which one will discharge over there. So here we can see that under ideal condition, the condition in which it is taken as dilute and inert electrode, so copper and hydrogen will migrate towards cathode. But down the series, if you see here, copper is below hydrogen, so copper will easily discharge over there. So at cathode, which is going? Copper is going, because copper is down the electrochemical series of metal, so it will discharge over cathode. Now the question comes that which one will migrate towards anode? Here sulfate and OH both will migrate towards anode. But the condition is that since it has been used as dilute and inert electrode, so down the series sulfate is much more higher than OH. Hence OH will migrate and get discharged over anode. Now another question arises, what are the different reactions that happens in cathode as well as anode? As we have understand that at cathode ultimately copper is being discharged, so we will try to write down the equation at cathode and equation at anode. So the reaction at cathode will be Cu2 plus, it's taking plus 2 electrons, gaining of 2 electrons, that means what? It becomes copper. And reaction at anode, already I said that OH is down, so here SO4, so it has been discharged over the anode and the reaction becomes this. So this is the under ideal condition when the electrolyte has been taken as dilute and electrode has been taken as inert electrode. Now suppose the second condition is, suppose here the second condition we have taken the it may be dilute, Number 2 condition, second condition is if it is dilute and instead of inert electrode, active electrode has been taken, let us say copper, and the electrode has been taken as copper, then what would have been there? When the electrodes is active, then the reactions, then the copper and the copper will migrate towards the cathode as well. From this remains the same, but at anode neither sulfate nor OH will get discharged, only there the copper will be discharged over here. That means we can write here Cu minus 2 electrons gives Cu2 plus. So this will be discharged at cathode, at anode, when the conditions are under identical conditions and the electrolyte is dilute, but the electrodes have been taken as active electrode, which is here copper instead of inert electrode. One of the last condition is during the electrolysis. Suppose under identical condition, अगर हम यहाँ पर concentrated अगर electrolyte लिए, चलो एक example लेते हैं concentrated electrolyte sodium chloride. Let us take here sodium chloride. One more condition during the electrolysis is, already 2 conditions we have learned. Now under identical condition, if the solution or the electrolyte has been taken as concentrated, let us take an example, concentrated sodium chloride. Here let us take concentrated sodium chloride solution will take. Then the reaction, what kind of the reaction we can see here? The reaction is NaCl gives Na plus plus Cl minus, then H2O gives H plus plus OH minus. Now the solution has been taken, here it is concentrated. So the cations are sodium and hydrogen. Though sodium has more concentration than hydrogen, here, but still hydrogen will migrate towards the cathode and it will get discharged over there. Here you can see the position of hydrogen. But what happens to the anode? At anode, we can see from here chlorine and OH both will try to migrate over there, but being OH at the down, then the down the series, then the chlorine, but due to the concentration, chlorine will get discharged over anode, and the reactions are as follows. So this reaction is at anode and this reaction will be taken as at cathode. Thank you.